All right, so this time we're going to be looking at a side example, and we're going to be solving for the missing angles here. So doesn't matter which angle we choose. All right, so let's say we're going to solve for this missing angle first, right here. So the important part is that 5 is the side that is across from the angle. So if I'm going to plug in like x for here, that means the 5 is going to get plugged in for the a over here. So it's always, the two sides right here. So 7 and 6 would be like my two sides. And this x is going to be the included angle. So if this is the included angle, then the side that's across from it has to be my third side on the other side of the equal sign. All right, let's go for it here. So I know A, B, and C, and I'm solving for this angle here. So if I do 5 squared is equal to 6 squared plus 7 squared minus 2. This is still going to be 6 and 7. And it's going to be cosine of A or cosine of x. This is the angle that I'm solving for. All right, 5 is across from that angle. Let's see here. So I'm going to get 25. This will be 36. This will be 49. And then 2 times 6 times 7, that is like 84. 84 sounds about right. Times cosine of x. I need to combine those. So let's do that. 25 is equal to 85 minus 84 times the cosine of x. And then I'm going to move my 85. So subtract that from both sides. That's going to give us negative 60 on the left side and negative 84 on the right. Cosine x. Okay. We're going to, we can get rid of the negatives. We're going to divide by 84. So divide by 84, divide by 84. And let's see. I feel like simplifying this. I could simplify this by 12. That's going to give me a 5 on top and a 7 on the bottom. And that's equal to cosine of x. Okay, so now I just need to do my arc cosine or my inverse cosine to this. And that's going to tell me what my angle is. All right, so if I do inverse cosine, 5/7, that's going to give me a 44-degree angle. So I'm going to do cosine inverse of 5/7. All right, and that's going to tell me what my x is. That's equal to 44.4, and that's equal to my x. So I got one angle, 44.4. Okay, got that. Now, if I wanted to, I could set up another equation, another law of cosines equation to solve for this angle using the exact same scenario. Like I could take my 7 squared and just put that right there, and take my 5 and put that right there, and then run through the process again, and that could help me solve for my my other angle. But it's once you have an angle and the side that's across from it, it's just so much easier to use the law of sines. Okay, so from here I'm gonna jump over to the law of sines. So sine of 44.4, that one is across from my 5. And I'm going to use this to solve for the angle that's across from 6. So we'll call that angle y. Sine of y. And that one's across from 6. All right, so to solve this, I need to multiply through by 6. So multiply by 6. I'm going to multiply this by 6, like that. This is going to cancel. And so what I need to do is I need to evaluate this side and then do the inverse sine to that. And that's going to solve for my y. All right, so I'll just use my alpha y equals here. So 6 times the sine of 44.4 over 5. But now I need to do the inverse sine of that. Inverse sine of my last answer. That's 57.1. 57.1. Yeah, just that one's going to round that one up and all together. So that means my angle y is 57.1. Got it, got it. And then from here, you could use the law of sines again or the law of cosines again. But we know that all three of these angles, they got to add up to 180. So let's just do it that way. 180 minus 57.1 minus 44.4. So this last angle has to be 78.5. There you go. If you've got a triangle, if you know all the sides, you can use the law of cosines, set up a big old nasty equation, and work it out from there. I'll do another example here where instead of having to solve the equation like we did here, sometimes they give you a special formula to solve for the angle.